When melting ice threatens to flood a northern town, an amphibious ice machine offers a modern solution to an age-old predicament.
We're very motivated to see this completed every year. If we don't break this ice, there will be flooding.
Patrolling over the frozen north, this airborne ice machine ensures the Canadian Air Force can protect its land.
If you think of the Canadian Arctic, there's very little capacity up north. So anywhere we go, we have to bring everything that we need with us.
Carving an icy path from the Arctic waters of Sweden to the North Pole is the most powerful icebreaker the world has ever seen.
We're going to the high Arctic, where it's very difficult to get any help.
Where frozen wilderness exists. Where snow and ice are relentless. And where exposure to the elements is a matter of life and death. Human survival depends on extreme ice machines. In Selkirk, Manitoba, lies the 550-mile mighty Red River. Come spring, as the ice melts, Selkirk is susceptible to ice jams, and the result? Devastating floods. To clear the river and protect the 10,000 residents, locals have come up with an innovative solution. Adapting a dredging system to keep homes safe, where humans and machines work hand in hand to prevent disaster. Meet the Amphibex AE400E, a 22-ton, 35-foot-long amphibious barge. Originally built for river dredging in warmer months, it has been repurposed as a signature spring fix for flooding in Selkirk. Equipped with a 6-cylinder diesel engine and a 132-gallon hydraulic system, reinforced excavator arm, and 2 hydraulic steel can stabilizers, this green monster drags itself up the river every spring, destroying ice in its wake. Leading the mission is veteran icebreaker Brian Sparks.
Amphibex, amphibious excavator, used for dredging and ice breaking in our application. We've been doing that for 15 seasons now on the Red River. Are you guys good to go? Let's break some ice, boys.
Ice breaking on the 17-mile span of the river is a 6-week operation. But for the Amphibex and the North Red crew, every minute counts. Starting too early or finishing too late can have devastating consequences.
If you wait too long, the runoff is coming. If you start too early, it'll refreeze in place. So it's a timing thing that we have to get right. We work 24 hours a day, 2 12-hour shifts, 6 guys on each shift. Probably a month straight before we see a day off.
For many of the crew, passion and dedication for ice breaking on the Red River comes from personal experience. And none are more committed than the program's director, Daryl Kupchik.
This job, breaking ice, there's no other job like this. We've all been exposed to flooding. We live in Manitoba. We know people that have flooded. Personally, my parents' house has flooded along the Red River. We're very motivated to see this completed every year. If we don't break this ice, there will be flooding.
Amphibexes work in teams of 3 as they make their way down the river. Their process for ice breaking is a unique one, but the principle behind it is simple: gravity.
The Amphibex itself does not break ice with the bucket. What it uses the bucket for is it extends that arm out and it pulls that 22 tons of steel, the hull, up on the ice, and the weight of that hull will actually cause the ice to fail.
Originally built for quick repairs on some of the most remote rivers in the world, the Amphibex is comprised of a 35-foot QT100 steel barge covered in a corrosion-resistant one-piece hull. Powered by a 6-cylinder marine diesel engine, the Amphibex's 132-gallon hydraulic system is the lifeblood of this river monster, operating 5 hydraulic steel arms, including the excavator.
We have the bucket right here. This is the what grabs onto the ice for pulling the Amphibex along. Hooked up to the excavator stick and boom. The whole arm of hydraulic operated, mounted onto the front of a barge-like vessel.
In case of spills, they use biodegradable hydraulic oil with a freezing point of 44 degrees Fahrenheit. The Amphibex's load-sensing hydraulic pump produces a pressure of 5,000 psi, forcing the hydraulic pistons into their cylinders, retracting the arm at reinforced hinges. With a change of the valve, pressure is released, and the arm returns to its resting position. While the excavator arm hauls the Amphibex up onto the ice, its stabilizing arms keep this top-heavy boat balanced.
So these are the stabilizers. That's just an empty can, you might say. It gives lots of flotation, stabilization for when the boat's in the water and for when we need to stabilize on ice.
It's a wild ride for operators who are manipulating the Amphibex's many arms, but a brutal battle for the hydraulic system. Despite steel reinforcements of the Amphibex's mechanical components, constant collisions can only lead to one thing.
When an Amphibex puts its boom on the ice to pull itself up, if that ice fails and the operator isn't able to get that boom lifted, you shock the hydraulic components. When you repetitively do that, something's gonna go.
So far, the crew has made good time, but they're about to take on one of the most difficult passes on their mission.
This year is probably our strangest year we've had yet for ice on the Red River.
During the previous fall, high winds caused the Red River to freeze, thaw, and refreeze, producing frazzle ice, a dirty, debris-filled collection of randomly oriented ice plates. The frazzle ice has made the ice surface spiked, a threat to the machines that travel across it.
So that made it for some spots that are a little bit crazy. The other side of Selkirk Bridge is one of those spots. So we see what we run into when we get there.
It takes a small army of big machines to protect the town of Selkirk, and leading the charge ahead of the Amphibex is a custom ice cutter.
When the ice shifts, you'll get a big boom, just like thunder. It gets the ticker pumping, yeah.
In an ice-breaking battle to keep the town of Selkirk safe from flooding, a trio of Amphibexes take their position, awaiting direction from Supervisor Brian Sparks. The conditions under Selkirk Bridge are treacherous, and making their way along this icy wasteland will be detrimental to the machines.
So Dave, only Jamie's gonna go under the girders there. You and me are gonna go through the main part.
But the Amphibex isn't the only extreme ice machine out on the ice. Just a mile ahead is another unique ice-fighting solution created by the Red River team. Custom Bobcat ice cutters. These cutters create fault lines for the Amphibexes to crash through. And leading the charge is ice-cutting supervisor Tommy Komet. But you won't find him in the Bobcat. Tommy's custom cutters are remote-controlled.
It's a Bobcat with custom aluminum tanks filled with foam. There's 2 of them, 1 on each side. This way, if the machine were to go through the ice, it'll continue to float there, and we can hook a tow strap to it and pull it onto structurally sound ice.
The ice here in the Red River can reach 40, 50 inches thick. The Amphibex by itself could probably break about 15 to 20 inches. The ice cutters, in advance of ice breaking, provide a cut. The Amphibexes then follow that cut line in a diagonal pattern.
This is a remote control that operates the Bobcat. It's just as if you were sitting inside. The left control, the right control, all your components, the ignition.
The ability to cut through ice at a distance keeps the operators out of harm's way, because cutting straight through a sheet of ice can cause it to crack or shift without warning.
You get adrenaline going, especially while you're cutting. When the ice shifts, you'll get a big boom, just like thunder. Sometimes you'll even be able to witness the machine drop a little bit. It gets the ticker pumping, yeah.
Using a hydraulically powered chainsaw-like trencher attachment and experimenting with chains and tooth patterns, the crew has found their perfect fit, cutting through ice thickness of up to 5 feet.
We've tried about 6 different sets of teeth to make it efficient, and these ones we came up with, they don't wear out. They just got a carbide tip on them, and they don't wear. It just cuts ice like a hot knife through butter.
That doesn't mean that the Bobcats don't also have their challenges. While the carbide-tipped steel teeth may not wear out, the trenchers operating at a near perpendicular angle to the ice take the brunt of it. Daryl is overseeing a break that happened last night.
Last night, while the crew was operating, we had one of these ice-cutting trenching attachment split. And what happened then is we lost the end piece. Unfortunately, it went right to the bottom of the river. And thankfully, we were able to salvage the chain and the teeth. In the interim, we've outfitted this unit over here with a fresh chain and teeth. And so now this unit's going to hit the ice shortly, and we can continue operating.
As the maintenance team at the warehouse races to get the Bobcat back on the ice, trouble has also arisen for the Amphibex crew. A hydraulic cylinder has cracked, and the only option is to pull it out.
We got to pull it out with the hydraulics. It's stuck so hard in there you can't get it out.
It's -5 degrees Fahrenheit, and a race against time to get this crucial component back into operation.
Okay.
But this team is well versed in quick response and on-site repairs.
Yeah, so this is the stick cylinder that we're replacing. It goes from the top of the stick back onto the boom here. It controls the action of the stick. And they're just changing out the pipes on it right now, and we'll have it on in a few minutes. It broke from hydraulic pressure. The pressures get spiked when we're working in these conditions, the way this ice is, and that's the reason for it. Fix her where you broke her.
With no time to lose, the North Red team begins installing the replacement hydraulic cylinder. And with all hands on deck, the crew uses an adjacent Amphibex as a hoist to get the cylinder into place.
Okay, oh, right there.
It's a team effort, built off the back of seasons of Amphibex operating experience.
Anytime you put ice against steel and you add the cold weather and repetitive use, steel never wins. Steel always loses. And it's really our job to just reinforce it and try and balance the odds out a bit.
After a speedy turnaround on the hydraulic cylinder, the maintenance crew has the Amphibex back up and running. Survival is all about adaptation and protection from another season of flooding. No one knows that better than the Amphibex and the North Red crew. It won't be long now until the job is done, but rest assured, the Amphibexes and their dedicated crew will be back next spring, whether it's in the warehouse.
We always got to get it fixed and keep going and keep cutting ice.
Or on the river.
I love this job. Well, it's a unique job, and I just enjoy doing it.
Here, humans and machines rely on each other to survive. And between the Amphibex and the North Red crew, there's no stopping them.
We put it through its paces, we break it, we keep putting it back together, and it just keeps going. No matter what weather, how thick the ice is, we know it's going to continue to work. That's why this is an extreme ice machine.
When it comes to military operations in the Canadian Arctic, there's only one aircraft trusted to fight the elements.
There's no aircraft in the world that is capable of doing what a C-130 does.
The Canadian Arctic is a vast, cold, and desolate landscape. For the men and women who protect the North, moving supplies and personnel to the northern outposts dotted through the Arctic is a crucial job with lives depending on it. Stationed out of the Canadian Forces Northern Area Headquarters in Yellowknife, the Air Force provides a key lifeline for military installations serving and protecting the nation. When service members or a large load of supplies need to be transported, the Canadian military has come to rely on one aircraft, the Hercules C-130J. A 4-engine turboprop tactical transport aircraft with a rear cargo ramp designed for troop carriage, search and rescue operations, and the ability to move large payloads over great distances.
The C-130J is the right tool to operate in the Arctic. It allows us to fly into these small northern communities that are serviced by gravel runways, short distances, and we can carry 40,000 pounds of cargo and transport them into these communities.
Captain John Levesque is the aircraft commander of a tactical transport squadron and has over 2,000 hours of flying experience in the Hercules C-130J, most of it in the Arctic.
In the Arctic, we help out with search and rescue exercises. As well, we conduct a weekly resupply to Canadian Forces Station Alert, which is the northernmost permanent settlement in the world. It's located about 500 miles south of the North Pole on the northern tip of Ellesmere Island. The C-130J is definitely required to make the exercises a success.
Low master break. 4 crew. 30 packs, 34 people on board, and that's it. Okay, perfect.
Today, Captain Levesque and his squadron are transporting Brigadier General Patrick Carpentier, commander of the Joint Task Force North, and a group of international VIPs to a training exercise in Rankin Inlet.
For the exercise, everything is based around a simulated scenario to pick up parts of an aircraft that would have crashed in the Rankin Inlet area, and so we will be diving on the site, simulating, recuperating aircraft parts that would have gone through the ice.
Clear left. Clear the right. Here we go.
Today's journey will take them over 700 miles, a distance that represents just a small portion of the area these service members are tasked to defend.
If you think of the Canadian Arctic, there's over 8 million square kilometers with no roads, no highways. It's about the size of the continental U.S. That Canada has to project sovereignty over in the north. But really the only way to get up there on a daily basis when the time comes is by aircraft. And the C-130 is the only aircraft that can actually get there to the different unimproved runways that we have throughout the north.
Master Corporal Christopher Gilbert Lamontagne is the loadmaster on the Hercules C-130, responsible for the logistics in safe loading, transport, and unloading of cargo and personnel. The plane can be configured in a variety of ways to accommodate everything from vehicles to pallets of supplies to paratroopers.
So right now it's sitting on the bare floor position. And then if we need to load pallets, we have a little clip here. We just turn it, put your finger, turn it, as easy as that. And then you have to set your roller. So you would do the whole entire floor like that for all 8 pallet position.
The current J model is employed on missions all over the world, but it's in the Arctic that its unique systems are put to full use. Corporal Woodham oversees the technical maintenance on the Hercules C-130 and is responsible for ensuring that all systems are operational before, during, and after flight. In his capacity as technician, Corporal Woodham is constantly monitoring systems on the Hercules, including the de-icing and anti-icing equipment.
So right up here we have our first line of defense against icing. It's the icing detection probe. It's actually able to detect if we've started to get icing on the aircraft. It's actually able to warn the pilot, who can once again take appropriate action by turning on all the anti and de-icing systems. We have our pedostatic probes. We have 2 on each side. They're also heated. You don't want ice forming on your pedostatic probes. If you have that happen, you're not going to be able to detect either your altitude or your airspeed. So back here, we've got the bleed air ducts. This is the start of our primary defense against ice on the aircraft. We don't want ice on the leading edge of the wings or on the tail. So if we get ice there, you start to lose lift. We're going to actually take heat from the engines, what we call bleed air, and we actually pump it down through the leading edge of the wings. This right here, this black duct. If this was in flight, I wouldn't be able to touch it, as it would be hot, providing the bleed air to the leading edge of the wings. And that's nice and hot. It's going to prevent ice from forming on the wings.
Right now, we're at flight level 270, so 27,000 feet, and we're cruising at about 320 knots true airspeed, so that's roughly around 500 and some kilometers.
Brigadier General Carpentier has seen firsthand how valuable this extreme machine is to operations in the north.
The reality of northern communities is that there's very little capacity up north. So anywhere we go, we have to bring everything that we need with us. We have to be completely self-sufficient, and the C-130 is the truck that's going to help us do that.
Given the area the Canadian forces must protect, they rely on the Hercules' ability to cover great distances. It has a range of over 2,700 miles when carrying a payload of 40,000 pounds. And even with a cargo load that size, it's able to take off and land on short runways and varied terrain, which makes it an indispensable ice machine in the Arctic.
If you go to the north, you'll see that a lot of runways are by cliffs and glaciers and very hard areas to fly into. The C-130 gives us the flexibility to land in those locations and bring the help that we need to bring when the time comes. There is no aircraft in the world that is capable of doing what a C-130 does.
Upgrades to the J-model Hercules have only made it an enhanced extreme ice machine.
This section right here, where it looks a little bit thicker, and you've got what looks like a tape. This is actually a heating element.
The Canadian military has come to rely on the Hercules C-130J for its Arctic operations. It's an aircraft designed to withstand harsh weather conditions, with the ability to take off and land on short runways. For an average commercial aircraft, a landing strip at least 6,000 feet long is required, but not for this beast.
The C-130 has the capability to operate on gravel strips less than 3,500 feet in length. It's a massive aircraft, 133 feet wide, over 100 feet long, and the way we can fly it is it's quite a maneuverable aircraft.
It is gusty up to 35 knots in Rankin Inlet, so we can expect some moderate mechanical turbulence. The weather is anticipated to improve. Are estimating the airfield in about 30 minutes.
Originally built in the 1950s, the C-130 is still in production today because it's been able to marry elements of its original design with modern technological upgrades.
So we've got a combination of old school cable controls, but we've made it with a modern autopilot system. That black little servo right there, actually, that's the autopilot servo for them. So you can see it's also into the cables, so it has direct hookup to the hydraulic pack as well.
Along with the autopilot system, the latest model of the Hercules C-130 has key updates that give it improved flying capacity.
Compared to the C-130H model, the older model, the advanced C-130J model has newer engines. They're more efficient. They have a 6-bladed propeller, which is able to generate a bit more torque and create more efficiency. The engines are also digitally controlled by what we call a FADEC. It's a full authority digital engine control. It's essentially a computer that optimizes the engine efficiency. And each engine produces about 4,700 horsepower, and we have 4 of them.
It's the safety additions on the current Hercules model, married to the original design, that gives it the durability to withstand the harsh conditions in the Arctic, making it an essential military ice machine.
So coming out here to the propellers, obviously we don't want these forming any ice. This section right here, where it looks a little bit thicker, and you've got what looks like a tape. This is actually a heating element, and it's gonna prevent ice from forming on the propeller. The spinner up there, the big pointy section, it's also heated. Both of these are using electricity provided from the generators of the aircraft to prevent ice from building and melt any. So coming out here, I showed you the bleed air lines on the inside earlier. They're gonna run out into the leading edge of the wing here, starting at the fuselage, right out to the end of the wing. So continuing on to the back of the aircraft here, once again we have the bleed air, and they're gonna feed two things back here. The first one, same as with the wings. You've got the bleed air ducts running along the inside of the leading edge here, keeping that surface nice and warm, preventing ice buildup. And a new improvement on the J model Hercules that previous models didn't have is the addition of this de-icing boot. It's actually got the ability to inflate just a little bit when we have a heavy icing condition on the tail, which will actually break the ice off of the tail of the aircraft.
The engines and propellers are also protected with specialized de-icing and anti-icing mechanisms. The C-130J has been rated to operate down to minus 65 degrees Fahrenheit.
Consider speed 127, please. 127 set.
Approaching the runway at Rankin Inlet, the Hercules capabilities are put to the test. Low cloud cover and falling snow mean poor visibility, which significantly increases the difficulty of landing the aircraft.
1 mile to go to missed approach point. Check. 10 strong.
With the commander and a plane full of VIPs on board, there's no room for error for Captain Levesque and his squadron.
Visual at the runway. Landing. 50, 40, 30, 20, 10. Your yoke. My yoke. The C-130 is very capable at getting into small runways, and because it is so maneuverable, it can land in real diverse conditions.
The personnel have been safely delivered for their training mission, marking another successful flight for the Hercules C-130J and its crew. No other aircraft can carry as large a payload, take off and land on short runways, and withstand the unforgiving Arctic conditions like this extreme ice machine.
I absolutely love flying the C-130J. Every new mission has a new set of challenges. It's unique, and it is just a blast to fly.
Navigating its way through the icy grip of glacial waters is a massive icebreaker with an appetite for adventure.
We're going to the high Arctic, where it's very difficult to get any help.
Less than 100 miles south of the Arctic Circle, in the snow-covered reaches of northern Sweden, lies the sleepy port town of Luleå. Perched on the edge of the Baltic Sea, pace on land may be slow, but out on the water, it's a frenzy. This harbor is home to giants. From the port of Luleå, the Swedish Maritime Administration operates a fleet of Baltic icebreakers. In the winter months, these gods of sea carve routes to assist cargo vessels carrying essential goods to port towns along the coast. But come summertime, they sit unused. Except for double agent Oden. Oden is one of only 3 polar icebreaking and research vessels in the world, transporting scientists to the Arctic from across the globe to study how life survives in extreme locations and the region's changing landscape. Oden is a Swedish-built polar-class 351-foot-long diesel mechanical icebreaker. the largest in Scandinavia, weighing in at 9,600 gross tons. With 4 8-cylinder engines and a meticulously engineered propulsion system, Oden can deliver an output of 24,500 horsepower. Her square bow, unique hull shape, and oversized rudders match Oden's might with maneuverability. With additional flushing and rocking systems to shake her free of an icy grasp, Oden is designed to crack, crush, and carve her way to the world's north and south poles. Winter weather operations are winding down in the Bay of Bothnia, and Oden is preparing for summer missions.
The Oden is a Swedish icebreaker. She's also a research vessel. Wintertime, we operate along the Swedish coast, helping cargo getting in and out from Sweden and Finland. During summertime, we help scientists on research expeditions in mostly the Arctic.
Today, Oden is testing her recently installed control system. New technology doesn't always marry seamlessly with older machines. Oden can't risk anything that will derail her summer plans. Today's trial is crucial to ensuring she's ready for her upcoming mission. Icebreakers by nature take a beating, so it's imperative that Oden be in perfect condition, receiving and testing all upgrades before heading out on her next Arctic expedition.
Ja, kanon. Vi kommer ut sakta så tar vi det sakta och siktet på.
And putting her to the test is Oden captain Eric Anderson.
We're waiting to take the lines in, so the last line is coming in right now. Then we start moving. It's very important to maintain our icebreakers and upgrade them, since we're going to the high Arctic where it's very difficult to get any help. So we try to be as well maintained and as ready as possible. My focus is that we bring everyone home back safe. Safety is our main purpose.
With the last ropes finally pulled in, Captain Anderson calls for Oden's departure from the port.
Allt är nökt och propeller klar, ja. Tack för det.
And sea trials begin. Oden is one of only 3 polar icebreaking and research vessels in the world. Partnering with the Swedish Polar Research Secretariat, Oden became the first non-nuclear vessel to reach the North Pole in 1991. An impressive journey without the power source generated by the nuclear version. Since then, Oden has made more than 8 trips to the North Pole and 5 to the Antarctic. She's equipped with laboratory containers, a helicopter pad, sea intake and filtering systems, as well as a 6,500-yard deep sea winch and multi-beam echo sounder for 3D mapping of the ocean floor. Capable of traveling 27,000 nautical miles continuously for 100 days, her simple yet powerful mechanical design has made Oden the most called upon research vessel on the polar seas. And the man in charge of keeping her ship shape is Chief Engineer Jörgen Rundqvist.
As Chief Engineer, you're responsible for technical equipment aboard the ship, making sure we have all the spares we need in stock on board to take care of every situation.
Icebreaking is a science all its own. To be able to read the ice and use the tools at your disposal is a constant calculation of the variables at hand. Only seasoned sailors and engineers are capable of taking on the ice packs and flows the Arctic can deliver.
The process of breaking ice is just one continuous, seamless motion of several mechanics happening at the same time. You have the ship moving forward with the bow in the angle, and you have the ice static there. Then you push the ice down the same way as the propeller pushed the ship up on the ice. That's a continuous movement.
To achieve that continuous movement, icebreakers are built with 2 core components in mind. The first is a powerful propulsion system.
The Oden has 4 main engines, a total of 25,000 horsepower, which gives quite a lot of power.
That power starts with Oden's 4 8-cylinder diesel engines, which produce an output of 510 revolutions per minute for icebreaking. Oden's mechanical reduction gearboxes then convert the engine's power into speed, while propellers control acceleration depending on their pitch. Stainless steel nozzles, 5 yards in diameter, circle the propeller, giving a directed, rather than dispersed, propulsion force. But Oden's power is nothing without the second fundamental component of its design: its 2-inch thick, high-tension steel hull.
The hull of the Oden is designed rather different from other icebreakers, a bit more like a box. They have configured the angles to be more efficient. The older icebreakers have a more rounded hull, and the ice knife is the only straight line on the hull there. This ship, they decided to make the whole bow and the ice knife in the same angle in order to shear off the ice more easy.
The team behind Oden has worked tirelessly, preparing the mighty beast for her upcoming research missions.
Start failure.
Now, it's time to test the new technology out on the open sea. Oden is the largest icebreaker in Sweden and one of the most powerful in the world. Even more impressive, she lives a double life. During the winter, she provides safe waterways for ships arriving in port. And during the summer, she sets off for the coldest places on the planet. Her upcoming mission is to bring supplies to a ship called the Polar Stern, a world-class vessel that deliberately froze itself into Arctic icy floes for research purposes. And overseeing Oden's preparation is Captain Erik Andersson.
This summer, we're going to resupply missions to the German research vessel Polar Stern. After that, we're going on scientific expeditions up in the Arctic also.
Since Oden's exploratory research missions can take her deep into the Arctic Ocean for weeks on end, the controls, monitors, and alarms on board Oden are vital. These systems act as constant communication between equipment and command. And when help is hundreds of miles away, there can't be any miscommunication.
The control system is, let's say, the brains. It controls all the pumps, alarms, temperatures. We want to test all functions before going on any mission.
The main concern is making sure the engine is everything is up and running. And that was a start failure. It will take a little while for that engine to reset. Probably a worn starting booster. Hello, Marco. Yes. Okay. Hi. Okay. So now it's up and running.
Tested and true, the engine, propulsion, and flushing systems have all checked out. So with Captain Andersson setting the course, Oden makes her way out to open water. Now they have to challenge one final system, which gives the vessel unexpected icebreaking capabilities. It's called the healing system.
Yes, we're going to start up on third auxiliary engine because the healing system needs 3 auxiliaries online. So,
Okay.
the healing system we use on Oden is to basically rock the ship from side to side in order to reduce the friction against the water and ice.
Oden's healing system uses 3 auxiliary engines and several pumps. By pumping 100 tons of water from one ballast tank to another in just 6 to 8 seconds, the system shifts the weight of the vessel, creating the rocking effect needed to release the ship from the impending ice.
This is the actual pipe that transfers the water between the starboard and port side healing tanks. The propeller is mounted just inside here. But now we have verified 3 auxiliaries online, and we can give the start order to the healing pump.
Oden's healing pumps kick into action.
So right now we're healing towards the starboard side. You can sort of feel it in the ship and also see it outside that we're leaning over to the starboard side.
Jorgen checks to confirm all the healing system's responses are correct. Quick water shift from side to side is key to create the momentum that moves the ship.
Well, it worked.
Ship is ready. We're ready to go, both for icebreaking here in the Bay of Bothnia and also for this summer's mission.
As Oden makes her way back to Luleå, the crew now knows it can look forward to another season of icebreaking and discovery in the Arctic Ocean. A master class in machine versus nature.
I think all of us are impressed of how Oden handles. I think she's proven herself several times, both in the Arctic and also Antarctic.
The Oden could say is an extreme ice machine because it's purpose-built to do icebreaking in the Arctic. And it was the first non-nuclear vessel to ever reach the North Pole also. And we have been there several times since that, so I think we proved our point.
The Amphibex, the Hercules C-130J, and the Oden Icebreaker. 3 extreme ice machines that help make life and work in the North possible.
This job, breaking ice, there's no other job like this. If we don't break this ice, there will be flooding.
Amphibex, amphibious excavator, used for dredging and ice breaking in our application. We've been doing that for 15 seasons now on the Red River.
No matter what weather, how thick the ice is, we know it's going to continue to work. That's why this is an extreme ice machine.
The C-130J is the right tool to operate in the Arctic. It allows us to fly into these small northern communities that are serviced by gravel runways, short distances, and we can carry 40,000 pounds of cargo.
We have to be completely self-sufficient, and the C-130 is the truck that's going to help us do that.
I absolutely love flying the C-130J. Every new mission has a new set of challenges. It's unique, and it is just a blast to fly.
The whole of the Oden is designed rather different from other icebreakers, so we're more like a box. And they have configured the angles to be more efficient.
I think all of us are impressed of how Oden handles. I think she's proven herself several times, both in the Arctic and also Antarctic.
The Oden could say is an extreme ice machine because it's purpose-built to do ice breaking in the Arctic. And we have been there several times since that, so I think we proved our point.
In the frozen landscape of the North, the climate is an ever-present danger. Whether it's maneuvering down rivers to combat flooding, carrying military supplies and service members, or breaking through ice on Arctic missions, human survival has come to depend on these extreme ice machines.